It'll work.
Okay, so what we talked about yesterday was how to write the null and the alternative. Today we're going to talk about the types of errors that you can make in a hypothesis test. So yesterday was, this is my null, this is my alternative, I can reject, I can fail to reject. Okay, so if we reject the null, that means that we have evidence for the alternative, right? We have evidence that the alternative is true. Yeah, you with me?
Sure.
Okay. So, if we reject the null, but the null was actually true, that's going to be an error. We made an error, right? See what I'm saying?
Yep.
Okay, so we're going to talk about what those types of errors are, the consequences of them, and how we can control the errors. Okay, that's cool. Glad you think so. Okay, so basically we're going to assume that the null is true until there's overwhelming evidence that the alternative is true. Right? That's what we talked about yesterday. That's a hypothesis test. Okay, so there's going to be fluctuations from time to time. So yesterday we talked about if I assume that the population mean is 100, let's say, and I take a sample, am I always going to get a sample mean that's 100? No, I might get 99, 98, 101, 102. That's going to be just because of chance. And just because of variability, I might get a sample mean that's not equal to the population mean. Okay, until there's something that is very rare that's observed. So if I assume that the population mean is 100, and I get a sample mean of 80, do you think that that 100 is true?
No.
Probably not. 80 is really far from 100, pretty far from 100 at least. So that would be considered rare. So what we're going to do next section is figure out where that rare cutoff is. Okay. So I think you guys have this on the next page. Right?
Look at that.
Okay. Okay. So here's how the type of errors work. Over here,
What?
okay, over here we're going to put the null. The null is either true or false. And then up here, we're going to put our decision. Okay, we are either going to reject the null, so R stands for reject, or we are going to fail to reject the null. Now, if I do not make an error and the null is true, what should my decision be? We fail to reject. We don't reject the null. So this is going to be a good case. If the null is false, what should the decision be? Reject. Okay. If the null is true and I reject the null, this is going to be an error. If the null is false and I fail to reject it, this is going to be an error. These are called type 1 and type 2 errors. If the null is false and I fail to reject, this is a type 2 error. And it's always written with Roman numerals. I don't know why, but that's how you're going to see it. And then up here, this is going to be a type 1 error. You kind of just have to memorize which one is type 1 and which one is type 2. The way I've heard students memorize it in the past is fail to reject is type 2. So if you fail to reject when you should have rejected, that's a type 2 error. But you're just going to have to memorize those. So what we're going to be doing today is you're going to be telling me this is when a type 1 error would occur, and this is the consequence of that error. This is when a type 2 error would occur, and this is the consequence. Majority of the time, one of the errors is a lot worse than the other one. So normally, let's say type 1 might have much worse consequences than type 2 does, or vice versa. But it depends on the situation. It's not always that type 1 is worse or type 2 is worse. Okay, one thing to know is that a type 1 error is defined by alpha. So alpha is the probability of a type 1 error. Beta is going to be the probability of a type 2 error. They are inversely related. So as alpha increases, beta decreases. As beta increases, alpha decreases. So as I increase the probability of one error, the other one is going to decrease. With me? Okay. Okay. So here's how a hypothesis test is going to work. In the middle, you're always going to have to draw a diagram. But in the middle of our sampling distribution, we're going to put the null. And I told you, we're going to find some region or some cutoff where we say outside of that is rare. So whatever those cutoffs are, we're going to say that these two are our rare spots. So what I mean by that is if you get a sample statistic over here, let's say, so an X bar that's over here, I would reject the null. And then over here, if I get something over here, I'm also going to reject the null. Okay, so what I want with this figure is I want to figure out where a type 1 and a type 2 error occur. So, if I get an X bar that's here, let's say. So let's say that our mean is 100 and I got an X bar that was 80. Okay. It's my palm. Okay, so if we get a mean that's 100, or we assume a mean of 100, and we get a mean of 80, what should the decision be? Reject, right? It passed our like rare standard. Okay, in the case where this is actually true, but I get this, so my null is true but I reject, this is a type 1 error. So this is the case where a type 1 error would occur. Okay, so then let's say that we get a mean that's here. We get an X bar of, oh, this doesn't even make sense, guys.
That's what I was about to say something, but I thought you were going to get mad. So.
Does that seem like something I would do?
Yes, absolutely.
Okay, 120, does that make more sense?
I didn't realize it.
Okay, so 120. So then here, let's say this is 108. Does that make sense?
Yeah.
Okay, so this is 108. So if we get a sample statistic of 108, but maybe our true mu is 130, we're going to fail to reject. This 108 falls within the boundaries. But our true mean is 130. You kind of get where I'm going with this? No? Okay, we're just going to do an example. How about that? Let's just do an example. That I just wanted you to see it graphically. I'll show you again when we actually start doing this. Oh yeah. Okay. This one is interesting. I don't know if it's going to show up very well though. Okay. So let's think of a real world example. So let's think of the case of a fire.
Oh, is
Football.
Football.
What?
Super Bowl.
I'll have to think on that one. Okay. So either there is a fire or there is not a fire. Okay. You guys can just write this somewhere. Just find somewhere to put it. Okay. Not that big of a deal. Either there is a fire going on or there is not a fire going on. And then up here, rather than like decision, we're going to have alarm. Either yes, there's an alarm going off, or no, there is not an alarm going off. Okay. If there is a fire and there is an alarm going off, this is a good case. I mean, it's not good that there's a fire, but it's the right decision.
It's a small fire, just light a match, isn't it? It could be big to an ant.
Self-respectful.
Too human.
You. I've got nothing.
Okay. Good. Now, if there's not a fire going off and there's no alarm going off, this is a good case also. If there is a fire but no alarm, this is a bad case. If there is no fire but there is an alarm going off, this is bad also. Okay, so we have two errors. Is there one that is worse than the other? Yeah, right? So if there's a fire going off but no alarm, this error is going to be much worse than this error. Okay, so that's what you're going to do in a hypothesis test, is tell which one is worse. The reason is, let's say that this is our type 1 error, so this is alpha, and this is our type 2 error because this is beta. You know that they worked inversely. So you're going to have to decide, do I want to increase alpha and decrease beta, or do I want to decrease alpha and increase beta? So in this case, do you want a higher probability of alpha or a higher probability of beta? Beta. You're going to have a higher probability of beta, which is going to make a much smaller alpha. So that's what you're going to be looking at. This alpha is actually called the significance level. So you know how with panics, you guys always had the confidence level?
Yes.
Okay, for a hypothesis test, you have what's called the significance level. Okay, so this is what you're actually going to be doing with this, is you're going to be given something like this. So suppose that, I think you have this on the previous page, sorry. Suppose that you are inspector for the Fish and Game Department. Whoa.
Ideas.
What happened? Okay. Suppose that you are an
You pressed that.
I don't want to hear it, okay?
So what kind of alarm is it? Is it a smoke detector or?
You're still stuck on the question? Can we move on?
It's the one on your phone that wakes you up.
Okay, moving on. Suppose that you are an inspector for the Fish and Game Department and that you are given the task of determining whether to prohibit fishing along part of the Oregon coast. You will close an area to fishing if it is determined that the fish in that region have an unacceptably high mercury content. Assume that an acceptable content level is 1.450 parts per million or less. Okay, so first thing that we have to do is we have to define our hypotheses. You can't determine what the errors are if you don't know what the null and the alternative are. So let's do that right now. First of all, what symbol are we going to use? Mu. There we go.
What?
Write this down.
It's,
I feel like this is just so slow. Okay.
You can tell what it says.
Yeah.
Yeah, it's okay.
Okay. Mu is the population mean mercury content. Okay.
You've come a long way. You would have given up before.
Why did you draw two slides? I'm just kidding.
Didn't we talk yesterday about being cooperative? Okay. So the null should be the easiest one. It's always going to be a statement of equality. The only number they gave you is 1.45. So you're going to assume that the null is mu is equal to 1.45. What is our alternative then?
It's a greater than. Greater than.
Okay, so what are we looking for? Are we going to look for evidence that there is danger, or are we going to look for evidence that people are safe?
Safe.
Safe, right? So they're safe if the levels are less than 1.45. So we're going to assume that they're not safe, and then we're going to look for evidence that the mean is less than 1.450.
Wait, one more time. Explain that.
We're going to assume that they're not safe, and then look for evidence to the contrary. People are going to be safe if the average is less than 1.45 parts per million. With me?
Yeah.
Why are you, why wouldn't you assume they are safe and look for why they're not safe? Look for evidence that they're not safe.
If someone was doing this for you, would you prefer that they assume that you're safe and, like, you're drinking
Okay.
water, let's
Yeah,
say?
that's true. Okay, gotcha.
Right, you're gonna want them to look for evidence that your drinking water is okay. Right. Okay.
Too soon.
Okay, so you're gonna need to write this out in words. If the mean is equal to 1.450, or remember greater, because that's kind of implied, then the fish have an unacceptably high mercury content, right?
Yeah.
Fish have an unacceptably high mercury content. And if the mean is less than 1.45, they do not have an unacceptable mercury content, so I'm just going to write that we're safe. I don't have the patience to write it anymore.
Yeah, I didn't. I just wrote fishing ain't safe and fishing safe.
Okay, explain type 1 and type 2 errors in context, and then describe the consequences of each. Anything like that? Oh, man. Okay.
Is that an emoji? That's your face right now. It's just a blank face.
You know what, guys? It really is difficult to write with this thing, okay?
Oh, no. What? Two different force.
You're gonna have to deal with it, okay? That's the best I can do. I'm not gonna go through erasing
From the
it.
AP review, I noted that you used two. You spelled out the word and you also used the numerical.
You use the number 10 and then the word 10.
I like to bug you guys. I'm glad I'm good at it.
You like put the bars on top of the type 2?
No.
No.
That's pi.
Type 3.1415.
Okay, so a type 1 error means that you reject the null, but the null was true. Okay, so if we reject the null, that means we conclude that the average mercury content is less than 1.45. So we're going to conclude that the average mercury content is less than 1.45 parts per million. This is not an error yet. This is just the rejecting part. So I'm rejecting the null, so I'm concluding that the alternative is true. So I'm concluding that the mercury content is less than 1.45, but this is not true. So I'm concluding that the alternative is true when it's not. Okay, so besides saying what the error is, you also are going to have to say what the consequence of this error is. So if we conclude that the average mercury content is less than 1.45, what do you think they're going to do?
Allow the people to fish.
Keep people fishing.
Less than 1.45
Is safe.
is safe, right? So you're going to allow fishing when it is actually unsafe. Okay, so that's our type 1 error. Type 2 error, remember, fail to reject. So I'm going to fail to reject the null, which means I'm going to conclude that the null is, or I'm going to believe the null is true, but it's actually false. Okay, if I fail to reject the null, it means I continue believing the null. So I'm going to continue believing that the mercury content is too high. Because remember, that was our assumption. We were assuming that people were in danger. So we're going to continue believing that the mercury content is too high when it is actually not. Okay. So if we fail to reject the null, so if we believe that the mercury content is too high, what are we going to do?
Stop
Stop
fishing.
fishing.
Stop fishing. So the consequence would be we are going to stop fishing. Is it the Oregon coast? Yeah, on the Oregon coast. When it is actually safe. Okay, so I cannot stress enough that when you write the error, you need to hit both parts. You need to hit the failing to reject, and then you need to actually say that it's false. The error is not the fact that you're failing to reject. The error is that you are failing to reject when the null is actually false. So then the last question says, do you prefer a significance level of 0.1 or 0.01? So significance level is alpha. So do we want 0.1 or 0.01? Okay, so alpha is going to be the type 1 error. Alpha is the probability of a type 1 error. So, first thing, which error do you think is worse, type 1 or type 2?
Type 1.
Type 1. So you're going to want a smaller alpha. You are going to want a significance level of 0.01. And then you would say, I would prefer a significance level of 0.01 because a type 2 error has worse consequences than a type 1 error. So I want to minimize the probability of a type 1 error. That makes sense? This is what section 2 is. You're going to write out your null and your alternative. You're going to write out the errors, and you're going to pick a significance level.
Is this the next part of Phantom?
No, this does not come up in Phantoms. But I do have to stress that I'm very picky with the way that you word the error and the way that you word the consequence. So you need to be very particular in your wording. Don't just pick random. Like, you really have to think it through to make sure you're getting across the point of it's an error and then what the consequence is. Questions? No? Okay. I think that's it for this section, at least for